Welcome back to class. I am Lavinia Heaton, and today we're going to look at writing equations of lines, still under that general topic of linear functions and slopes. Now, if you will recall, we have a slope formula here, which is slope equals y sub 2 minus y sub 1, divided by the quantity x sub 2 minus x sub 1. And then we took that slope formula and put in a general y and a general x here and got the point slope form of a line, y minus y sub 1 equals m times x minus x sub 1. And today we're going to use that to help us write the equation of a line. So we are down here to writing the equation for the line with slope 4. Passing through 1, 3, and we're going to write it in two forms, in the point slope form, which we see already, and we'll have to figure out what slope intercept form is, and we'll do that as we go along. When we're given the point 1, 3 and the slope equals 4, if you'll recall, and we're going to start with the point slope equation of the line. So remember that was y minus y sub 1, which will be the y of the point. So I have y minus 3 equals the slope 4 times x minus x sub 1, which is the x of the point. That is our point slope form of the line, and that's our first answer. We're already through with it. Now let me just tell you that to get into point slope form, what we're going to do is solve this equation for y, and then we'll look just a little bit further at why that works the way it does and why it's called slope intercept form. Okay, solving for y, we're going to first of all use distributive property. So we have y minus 3 equals 4x minus 4. And if I want to solve this for y, then I need y by itself. So the opposite of subtracting 3 would be to add 3. So I'm going to add 3 to both sides, and now I'm left with y equals 4x minus 1. And that is the slope intercept form. What about this 4 right here? Wasn't that our slope right up here? And let's see, what is a y-intercept anyway? Well, this is our x-axis, if you'll recall, and our y-axis. If I am anywhere on that y-axis, I've moved left or right, none. Notice if I plug in 0 for x, and do the arithmetic, I get -1 for y. If I graph that point, it is actually on the y-axis right there, isn't it? So we can read -1 as the y of the y-intercept, and we can read 4 as the slope very easily in that form. That's why we call it the slope intercept form. Now let's go back to our first page and try something. What if I decided that my slope was m for a particular line, and the point is going to be the y-intercept? That means x is 0 because all along the y-axis we've moved left or right, none. And we're just going to call b the y of the y-intercept. Traditionally, we do that. And then I'm going to plug in the point slope form. And I get y minus b equals m times x minus 0. Which goes to y minus b equals mx. Didn't plan ahead well, did I? Okay, adding b to both sides, I end up with y equals mx plus b. So that happens every time we're given a slope x and the y-intercept of b, that when it's solved for y, the slope is the coefficient of x, and the constant out here is the y of the y-intercept, or some books just call it the y-intercept period. So let's add this to our list of formulas that we have now. This is the slope-intercept form of the line. Form of a line. Y equals mx plus b. With this formula, it's a little easier to see that we have y to the first power and x to the first power, which is a requirement for a linear equation. We don't have second power, third power, absolute value, square root, whatever else in the equation. We have a y to the first power and or an x to the first power. Okay, so let's see what we're going to do with the next problem. Our next problem gives us another point and slope with the same directions. Write the equation of the line through the point 10, -4 with slope -3/5. So point slope first will be y minus the y of the point. Remember, we've got that case of minus in the formula, and minus for y equals the slope, -3/5, times the quantity, x minus the x of the point. So taking care of the double minus, we get y plus 4 equals -3/5 times the quantity x minus 10. And that is our point slope form of the line. We like to take care of the double minus for our final answer. And now to get the slope intercept form, we will solve this little fella for y. So we'll start with doing distributive property on the right side. So bring down the left just like it is, and then -3/5 times x is -3/5 x. Negative times negative is positive, and 3/5 times 10. Let's look at that on Scratch. 3/5 times 10. Well, I can reduce because 5 is a factor of the whole denominator. 5 is a factor of the whole numerator. So I have 3 times 2 divided by 1, or 6 here. Erase our scratch here because we don't want it in the middle of our problem. And now all we have to do to solve for y is to subtract 4 from both sides. So we have y equals -3/5 x plus 2 for our final answer in the slope-intercept form. Now a lot of people traditionally have called this the slope y-intercept form, so we don't even get confused as to which intercept we're talking about. So you might like to think of it that way, slope y-intercept, so you stay on track. Now you will notice me starting with point slope form of the line rather than slope-intercept form, and some of you may have been taught in high school to start with the slope-intercept form. I don't mind which you do, but think of this. You've got to be sure you have the y-intercept before you plug in a y for b. When you're doing y equals mx plus b, you don't choose the y of an ordered pair you're given unless its x is 0. So be cautioned there if you want to use the other way. But this is our point slope form. This is our right here. And this is our slope intercept form. Well, moving on to the next problem, we're given 2 points this time. What are we going to do? We're not given a slope. Oh, but we had a slope formula, didn't we? Yeah, I think that's what we'll do. So turning back to our pad, we're going to say that we have a slope that we don't know, and we're going to pick a point because we want points and a slope to work our point slope formula. And I think I'm going to pick 1 minus 1 just because it has less negatives in it. So we said we were going to have to find the slope, so that's our first step. Find the slope. I think we know how to do that. So let's come and we say m equals y sub 2. Well, maybe we better label these points. Since I chose to use 1 minus 1 already, I'll call it my first x and y. And I'll call this my second x and y, the negative 2, negative 4. So now y sub 2, negative 4, minus in the formula, y sub 1, minus 1. Then x sub 2, negative 2, minus in the formula, 1. That gives me negative 4 plus 1 divided by negative 2 minus 1 is negative 3. So our slope then is what? Negative 3 divided by negative 3, which is 1. Okay, after we found the slope, we can use the point slope form to write the equation. So I'm going to go to the next page and write down what we have. We have slope 1, point 1, negative 1. So slope equals 1. Our point is 1, negative 1. Okay, and we're ready to write the equation now. So that's our second step. We found the slope. Now we'll write the equation using point slope form. So y minus in the formula, y of the point, equals slope 1 times x minus x of the point. Again, we don't want to leave a double minus, so we'll call that y plus 1 equals, and 1 times anything is just that same thing. So I'm going to put it in this form for our point slope form of the line. And then next we'll go to getting our slope-intercept form. We solve for y. Well, if we subtract 1 from both sides, we'll have y real quickly this time, won't we? So y equals x minus 2, and that is our slope y-intercept form of the line. We can see the slope 1, understood 1 there, and when we plug in 0 for x, we get minus 2, so y equals negative 2 is our y-intercept. I kind of like to have an ordered pair so when I get ready to graph it, I don't forget what that minus 2 means. Okay, now we're given something a little different here. We're given an x-intercept and a y-intercept. What does that mean? If the x-intercept's 4 and the y-intercept is negative 2, are we being given an ordered pair 4, negative 2? Well, let's play with that a minute. If I wrote this, and don't write it on your paper, but if I wrote this as a point like this, and then I got ready to graph it, okay, if I graph 4, negative 2, look where it is. It's not on the x-axis or the y-axis, is it? So having a single ordered pair made out of the x-intercept and the y-intercept just doesn't cut it, because we're not on the x-axis, we're not on the y-axis. So let's think again. What does it mean to be on the x-axis and the y-axis? We're going to erase that because we didn't like that at all. What does it mean to be on the x-axis or y-axis? Well, if I'm on the x-axis, my y is 0. So my ordered pair that goes with x-intercept equals 4 is 4, 0. If I'm on the y-axis, I've moved left or right, none. So 0 for my x and my negative 2 for the y of the y-intercept. I now have 2 points. What I need is a point and a slope to write the equation in point-slope form. Well, I think I will pick 0, -2 for my point. Pick either one of them. And my task, first of all, is to find the slope. So, number 1, find the slope, like we did in the previous problem with 2 points. So, m equals, well, let's see, let the top one be the first x and y. Nah, we've decided to use 0, -2 here, so why don't we let it be the first x and y. Then this will be x sub 2, y sub 2. And I don't think this little fellow wants to write up here very badly. Have to write upside down to get him to write. I think you can kind of imagine that that's x sub 2 and y sub 2, because that's just a mess here. Doesn't even want to erase. Okay, going back. We take our y sub 2, which is 0, minus in the formula, -2 for y sub 1. X sub 2 is 4, minus in the formula, x sub 1 is 0. So I get 2 divided by 4, which reduces to 1/2. Now remember that when I reduce by 2, 2 goes into 2 once. So I have a 1 in the numerator. I didn't wind up with 2. I wound up with 1 over 2. So my slope is 1/2. Okay, let's go to the next page and copy what we have. We have a point of 0, -2, and a slope of 1/2 that we are working with from the other page, because we made it a point to get a point and a slope. Okay, using point slope form, y minus in the formula, the y of the point, equals the slope times x minus the x of the point. So I have y plus 2 equals, well, x minus 0 is just x. So when I distribute, I get 1/2 x minus 0, which of course goes away. To finish solving for y, I will subtract 2 from both sides and get y equals 1/2 x minus 2. Okay? So, what do we have here? Let's erase where we have done this. Right here is our point slope form of the line. Some books may have you list it y plus 2 equals 1/2 x minus 0, like that, the quantity x minus 0. Others say, well, if it's a 0, go ahead and simplify it. So, just do what your book or your homework instructions say to do. And there is our slope y-intercept form of the line. Okay, for our next session, we're going to be looking at graphing lines. Once we have the equation, what can we do to graph them? I'll see you then.